Hello everyone. We are going to perform the first experiment of linear integrated circuit, that is on the measurement of op-amp parameters. In this experiment, we are going to measure input bias current and input offset current, input offset voltage, slew rate and CMRR for the operational amplifier ICs OP07, LF356 and 741 IC. Objectives of performing this experiment are to build the op-amp based circuitry on the breadboard, to check how to power the op-amp, to measure the input offset voltage, input offset current, input bias current, slew rate and CMRR. Also, we will observe the output voltages on the multimeter and waveforms on the CRO, and we'll compare the datasheet parameters with the measured parameters. These are the components you require: breadboard, op-amp IC, resistors, DC regulated power supply, signal generator, CRO and digital multimeter. If we see the pin configuration of op-amp, it is a 8-pin IC where pin number 1 is offset null, pin number 2 is inverting input, pin number 3 is non-inverting input, pin number 4 is negative VCC, and pin number 5 is offset null, pin number 6 is output, and pin number 7 is plus VCC, and pin number 8 has no connection. So to generate a dual power supply for the op-amp, we need to connect two single power supplies together to generate a power as well as the ground points for the circuit. So connecting two single power supplies, we are connecting the positive terminal of a first single power supply to negative terminal of a single power supply, and that will generate the common ground for our measurements. Then the first power supply negative will be called as a minus VEE, and second power supply positive will be called as a plus VCC, which will be given to pin number 7, and minus VEE will be given to pin number 4, and all input as well as outputs terminals will be connected with the help of a common line or a ground line. So op-amp do not have any ground pin as a connection. For measurement of input offset current, we need to understand what is the input offset current. So op-amp has two terminals and there is a current inside the two terminals of the op-amp. We call it as IB1 and IB2 respectively. And if we take the difference of these currents, absolute value of difference of these currents, it will give us input offset current. If we take average value of these same currents which are entering into inverting and non-inverting input terminals of op-amp, it will be called as a average current or bias current. This is the particular circuit which is used for the measurement of op-amp input bias current and op-amp input offset current. So we are using the two 2.2 mega ohm resistors. The point connected is from inverting terminal of op-amp to the output through 2.2 mega ohms. This is going to measure IB1, and there is another resistor connected from pin number 3 to ground, which will be called as points C and D, and these 2 points will be called as A and B. So measurement of input bias current entering into non-inverting terminal can be calculated by shorting the terminals A and B. So when you short the terminals A and B, there will be certain output voltage VO1, and the input bias current entering into the non-inverting input terminal will be given by VO1 upon RB1. Then we have to remove the short across A and B and connect the short across C and D and measure the output voltage VO2. So that the bias current into the inverting terminal in that case will be IB2 is equal to VO2 upon RB2. So RB1 and RB2 are having value 2.2 mega ohms. So you can easily calculate the average, that is bias current, and you can also calculate offset current, which is a difference of the two currents. Next parameter to measure is input offset voltage. So input offset voltage is voltage which is to be applied between two input terminals of op-amp for making the output voltage 0. So this is the setup for measurement of input offset voltage. So op amp is configured in the non-inverting mode, and there is a feedback resistor of 100 kilo ohm, and there is a input resistor R1 of 100 ohm. Gain of this amplifier will be given by 1 plus RF upon R1. So presently there is no input applied to the terminals of the op amp, and both the input terminals are connected to ground. So corresponding to this condition, the output voltage will be measured, and then input offset voltage will be given by VIO is equal to VO upon 1 plus RF upon R1. Third parameter we are going to measure, that is a slew rate. So the output of an operational amplifier can only change by a certain amount in a given time. So this limit is called the slew rate of op amp. So even if we are applying a input square wave and the slew rate of op amp is not sufficient, it will be generating this kind of a trapezoidal wave shape. Output is limited by the slew rate. So we have to carry out the measurement of the slope of this particular trapezoidal wave shape to calculate the slew rate of op amp. So slew rate of op amp is delta VO upon delta T, which is a uh, measurement done on the trapezoidal waveform. So to generate a trapezoidal wave shape for measurement of slew rate, we connect the circuit in the voltage follower mode, and we apply high frequency and high amplitude signal at the input of the op amp. So this is 10 kilohertz 5 volt signal which is applied. Then increase the input frequency till the output waveform becomes trapezoidal in shape, and then observe the waveform on CRO and calculate the delta VO upon delta T. The last parameter which we want to measure is a CMRR, common mode rejection ratio. In the op amp, the output voltage is proportional to difference between the voltages applied to its input terminals. When the two input voltages are equal, ideally the output voltage should be 0. A signal applied to both input terminals of op amp is called as a common mode signal. Usually it is an unwanted noise voltage. So the ability of op amp to suppress the common mode signals is expressed in terms of a common mode rejection ratio of the op amp. So this is the particular circuit used for the measurement of common mode rejection ratio. So here you can see we are applying same input signal to both the terminals of op amp through this 100 ohm resistor. So you have to build the circuit on the breadboard, and we have to increase the amplitude of input signal at 1 kilohertz till measurable output is observed on the CRO. So measure input and output voltage VICM. So this is a common mode voltage VICM, and corresponding output will be VOCM. Then we can calculate CMRR is equal to differential gain upon common mode gain. So appropriate calculations can be done with these readings, and then converting the CMRR value in dB using the equation 20 log to the base 10 of CMRR, we can get the exact value of CMRR in the circuit. Now let us carry out the same measurements in the hardware.